Assalamu alaikum, everyone. Hope everyone is doing great. So let's get started with the live stream of S2. So today is the S2 day. There is S2 live stream in the morning, and then there is P1 live stream in the evening, actually night. So now let's get started with the idea that when we talk about S2, and when you are out to give the paper of S2, so what things needs to be considered? Now, from the examiner perspective, this examiner report that will tell you exactly what is the demand and what needs to be supplied. So now, S2, there are 5 major topics. And those topics are, the first one is Poisson distribution. The second one is a linear combination of random variable. The third one that we will do, that is sampling and estimation. The fourth one, that is a huge topic, that is hypothesis test with type 1, type 2 errors. And last but not the least, that is CRV. So there are 5 topics. This is 1, this is 2, this is 3, this is 4, and this is 5. Now we know that it's a 50-mark paper. So ideally speaking, a 50-mark paper should be thoroughly done in 50 minutes. And you are given 1 hour and 15 minutes, that is 75 minutes. So therefore, 25 minutes should be extra. So that is the ideal thing. And even if it exceeds, let's say 1 hour, still you would have 15 minutes. Now, what are the things that the examiner focus on? किन चीजों पे focus करता है? So I'll be keeping my language mostly English because there are students on the outside with a little bit touch of Urdu. So now it says candidates should be encouraged to read questions carefully. That is something very obvious, but if the examiner is emphasizing on it, that means the examiner wants you to take care of it. That's the first thing. And then it says extract the relevant information. So read, extract relevant information, and we will come back to it once we are doing some past paper questions, some yearly papers, and so on. So now that is the first thing. Candidates should be encouraged to reread the question when they have completed the solution to ensure that all the requirements have been fulfilled. So now these 2 things, they can be grouped together. Read and reread to make sure that you have answered something. Because sometimes we are in a mood and we give the answer, let's say, as x bar and sigma square, something like that. And they were asking maybe about hypothesis. So yes, that thing was necessary, but then you have to go all the way till the very last spot. Candidates should be reminded that in all questions, what needs to be done? So in all questions, a sufficient method must be shown to justify answer. That means show every single step. Do not compromise on that. When the question requires an answer to be shown, it is particularly important that all relevant working is presented with no steps omitted in the solution. So with no steps in the solution omitted, now these 2 things, they can be grouped together. So now show all working in a neat, logical manner. That thing has to be there. Then it says candidates need to keep, now it's about accuracy. So now let's group these 2 together. So about the accuracy thing, candidates need to keep at least 4 significant figures. Accuracy during working in order to ensure a final answer is given correct to 3 significant figures. That applies to P1, P3, M1, S1, S2. So that is a universal thing that you need to take care of. And then if questions are continued on additional pages, the question number must be clearly identified. So question number must be clearly shown. So now these are the key messages of this is May, June 2025. And this is probability in start 2. So the story is always the same. People make mistakes when they don't follow instructions. They try to innovate new things. They think they are overconfident and they can do whatever they want. So that doesn't happen this way. You have to supply according to the demand of the examiner. This is the demand of the examiner, which is in the key messages. Now let me go to another question, another paper. And it's the same thing over here. Now, this one is more elaborate. Let's focus on this. It says in all questions, sufficient method must be shown to justify answer. This was also written backwards. In the previous one, it is important that candidates read the question carefully, refer back to it, that is, reread when they have completed the question to ensure that they have answered in full. And then what else is there? Candidates are strongly advised to carry out all working to at least 4 SF. And if a final answer is required, so final answer that should be given to 3 significant figures, unless it is exact. For answers that are required in context, for example, some reasoning, things like that. So when some answer is required, so quoting general textbook statements, textbook statements will not be sufficient. Yes, you can write reject H0, accept H1, but in the context of that question. All questions, all working should be done in the correct question space. Yes, this is important, of the answer booklet. If the answer needs to be continued on additional page, it must be clearly labeled with the correct question number. We just read it. Candidates should only make corrections by crossing through and replacing the work, not by overwriting the answer. Very, very important. Some people, they write in pencil and then they write on top of it. That's not good. Only one solution should be offered. Do not make it a multiple choice question for the examiner. So now these are the main things that we need to take care of. So now if I add a page over here, and let's say, let me add a notebook, solid white, and over here, this thing, and S2 2026 guidelines. So now, if I'm writing things over here, so first thing first is that the examiner report, the gist is this: work in neat and logical manner, show all working, take care of accuracy, and if it's a reasoning question, then in context answer is required. So basically, these are the 4 things that is necessary in an S2 exam paper. So now let's pick topics and let's focus on them. So let's start with Poisson distribution. Yes, I might be taking some breaks in the middle so that you can refresh up and I can refresh up. So that thing will be there. So now when we talk about Poisson distribution, and if you have any questions, you can write in the comments box over there. And I won't be looking at it right away, but after some time, after I've done my explanation, then I can be looking at it. And those people who have my WhatsApp number, they can individually WhatsApp me. So now when we start this thing, this chapter, the very first thing that we refer to is the binomial distribution. So when we talk about binomial distribution, we know that X follows a binomial distribution with N comma P. N is the number of trials, P is the probability of success, Q is the probability of failure. Of course, you know that the binomial, the whole concept of S1 is completely involved in S2. Conditions, number of trials are fixed, number of trials are independent, number of trials are independent, so that is R. And probabilities are constant, and we know that probability of success plus probability of failure adds up to 1. Then we studied expectation of X as NP, that's called the mean, variance of X, that is NPQ, and normal approximation to binomial. So that's the condition that we apply. If NP is greater than 5, NQ is greater than 5, then X follows a normal distribution, NP, NPQ. So the mean goes over here, the variance goes over here. Continuity correction is a must, and you draw a number line, lower bound, upper bound, and you know exactly what to do. And we will, of course, see questions over here. When we talk about normal distribution, so X follows a normal distribution mu comma sigma square. The mean is mu, the variance is sigma square, Z is X minus mu over sigma. So you have to convert X to Z to find the probability. Then there are 7 rules, Poisson, linear combination. And this will be applied in this chapter and of course later on in sampling and all these things. So these rules will be there plus back solving. So now over here, binomial, normal, and now comes the Poisson. So the trademark of binomial is probability of success, number of trials. The trademark of normal distribution is mean and variance. Poisson distribution, it's about mean number of occurrences in a specified time or space interval. So now over here, when we look at this, X follows a Poisson distribution with lambda. Lambda is the mean number of occurrences, and it is different from normal, which has the trademark of mean and variance. And binomial is probability of success and number of trials and so on. So this is the kind of distribution. Now, real life examples of Poisson distribution. A telephone operator receives on average 6 calls in an hour. So this is the time period, that is the number of average. A meter length of cloth, this is about length, has 3 floors. The number of seeds spread in a meter square is 100. So this 100 is your lambda, and this is about area. The number of radioactive particles emitted in a day. The number of raisins in a fruit bun. The number of bacteria in 1000 ml of solution. So all these are examples of Poisson distribution. All got all clear? So now when it says X follows a Poisson distribution with lambda, lambda is the mean number of occurrences in a specified time or space interval. That is the formula. This E is that exponential E. X goes from 0 all the way till infinity. Conditions for a distribution to be modeled as Poisson. Yes, they ask this thing. The mean number of occurrences are independent. The mean number of occurrences occurs singly. The mean number of occurrences occur randomly. The mean number of occurrences occurs at a constant rate. So for example, if I talk about calls question, that is 6 calls in 1 hour. So I'll say the calls are independent of one another. The calls occur one at a time. The telephone operator receives 1 call at a time. The calls can occur randomly. Yes, in 1 hour, there should be 6 calls, but it's not necessary that it's equally spaced. The first 40 minutes, she could be free. Last 20 minutes, she could be receiving 6 calls. Occurs at a constant rate, 1 hour, 60 minutes, 2 hours, 120 minutes, and so on. So now this is the same thing that I just talked about. And then let me go to some past paper questions. And before that, so basic formula is this, but there is a range formula of lesser than or equal to. So if lesser than or equal to 2, you would use 2 terms. Lesser than or equal to 3, you will use 3 terms. Lesser than or equal to 4, you will use 4 terms. The first term is lambda power 0 over 0 factorial. This is lambda power 1 over 1 factorial. This is lambda power 2 over 2 factorial, and so on. Now let's look at this question. And of course, there is also linear combination. So linear combination of Poisson, simply add the 2 means. That is the basic idea. So now over here, the number of eagles seen per hour in a certain location has the Poisson distribution such and such. So that is 1.8. And the number of vultures seen per hour in the same location has the independent Poisson distribution 2.6. Find the probability in a randomly chosen hour at least 2 eagles are seen. So first of all, we will write X follows a binomial distribution, Poisson distribution, E for eagles, that is 1.8. At least 2, greater than or equal to 2, draw a number line, don't take any risk. What is left? 0 and 1. So 1 minus probability of 0 and 1, e raised to power of negative lambda, 1.8 power 0 over 0 factorial. You can write this thing as 1. 1.8 power 1 over 1 factorial. So I think I skipped a thing over here. Let me correct myself. This is 0 and this is 1. So this is power 1 over 1 factorial. And then this is the answer.